Good day, this is Sheena Pagaduan from BS Ed Math 2A, and for today's video, I will show you my solution in exercises 2.1 number 39. Let's start. Solve the matrix equation for A, B, C, and D. 1, 2, 3, 5 multiplied by A, B, C, D is equal to 6, 3, 19, and 2. First, let's denote the first matrix as A, second matrix as B, and the product of two matrices as AB. Then, the first step is multiply A and B. In multiplying A and B, we multiply the corresponding entries in the first row of A and the first column of B, where the first row in A are 1 and 2, and the first column in B are A and C. Then we get 1 times A plus 2 times C is equal to A plus 2C. Next, multiply the first row of A and the second column of B, where the first row in A are 1 and 2, and the second column on B are B and D. By multiplying 1, 2, and B and D, we get 1 times B plus 2 times D is equal to B plus 2D. Continue the pattern to complete the solution. Let's proceed to the next. Multiply the corresponding entries in the second row of A and the first column of B, where 3 is multiplied by A and 5 multiplied by C. Then we get 3 times A plus 5 times C is equal to 3A plus 5C. The next is multiply the corresponding second row of A and the second column of B, where 3 is multiplied by B and 5 multiplied by D. Then we get 3B plus 5D. By multiplying A and B, we get A plus 2C, B plus 2D, 3A plus 5C, and 3B plus 5D. The product of AB is equal to A plus 2C, B plus 2D, 3A plus 5C, 3B plus 5D is also equal to the product of the two matrices in the given problem. And this is the matrix AB is equal to 6, 3, 19, 2. We write this as A plus 2C is equal to 6, B plus 2D is equal to 3, 3A plus 5C is equal to 19, and 3B plus 5D is equal to 2. Using the four equations that we formed, we can now solve for A, B, C, and D. To solve for the value of C, I will use the equation A plus 2C is equal to 6 and 3A plus 5C is equal to 19. To solve for C, I will use the elimination method. First, multiply negative 3 in first equation, then add to the second equation to eliminate A, where A plus 2C is equal to 6 multiplied by negative 3. Then we get negative 3A minus 6C is equal to negative 18. Then we add this new first equation to second equation, where 3A plus 5C is equal to 19. By adding the two equations, negative 3A minus 6C is equal to negative 18 plus 3A plus 5C is equal to 19. We get negative C is equal to 1. Multiply both sides by negative 1. We get C is equal to negative 1. Now we have the value of C. We can now solve for A. using the first equation. The first equation is a plus 2c is equal to 6. Substitute the value of c. We get a plus 2 multiplied by negative 1 is equal to 6. Then we get a minus 2 is equal to 6. Add the additive inverse of negative 2. Then we get a minus 2 plus 2 is equal to 6 plus 2. Then a is equal to 8. To solve for b and d, we use the equation b plus 2d is equal to 3 and 3b plus 5d is equal to 2. First, multiply negative 3 in the first equation to form a new first equation, then add in second equation to eliminate b. b plus 2d is equal to 3 multiplied by negative 3. We get negative 3b minus 6d is equal to negative 9. Then, add the new equation 1 to equation 2, where negative 3b minus 6d is equal to negative 9 plus 3b plus 5d is equal to 2. Then we get negative d is equal to negative 7. Multiply both sides by negative 1. Then we get d is equal to 7. Now that we get the value of d, we can solve now for b. Using the equation b plus 2d is equal to 3, substitute the value of d. We get b plus 2 times 7 is equal to 3. Then b plus 14 is equal to 3. Next, add the additive inverse of positive 14. We get b plus 14 minus 14 is equal to 3 minus 14. Then b is equal to negative 11. Now we get the value for a, b, c, and d, where a is equal to 8, b is equal to negative 11, c is equal to negative 1, and d is equal to 7. To check if our answer is correct, we can substitute the value of a, b, c, and d to the corresponding equation. That's all for today. Thank you.